Now that you've learned how to classify matter into elements, compounds, solutions, and mechanical mixtures, it's time to actually look at what makes up an element. So all elements, the substances that we find on the periodic table, are composed of structures that we call atoms. The word atom in English is derived from a Greek word which is pronounced atomos, and when translated into English, this word literally means indivisible. So what this means is that an atom is the smallest unit of what makes up an element, and you can't break apart an atom into smaller pieces and still have it make up an element. So obviously you can't see atoms. Atoms are too small for any human or even any machine to see. So instead we represent what atoms look like in diagrams like this, which are what we call Bohr diagrams, named after the Danish physicist that first developed this model. Now, if we look at this diagram in more detail, we can see that there are two components to it. So we're going to start by looking at the component that we find in the center of the atom, which is where most of the mass of the atom is contained. This structure is what we call the nucleus. So this is where we get the English words nuclear, as in nuclear bomb or nuclear power, from. Now, if we were to look inside the nucleus, we would find that it actually is made of two different smaller components that we call subatomic particles. So subatomic is a word that means smaller, so sub means under, so smaller than the atom, and a particle is just a very, very, very small substance. So these two subatomic particles that make up the nucleus together, the first of which are particles that we call protons. So protons are small particles that have a positive charge, and we say that in terms of their size, because we can't measure the size, we say that they have an atomic mass of 1. There aren't really units to this because obviously you can't measure the mass of an atom on a scale, so the 1 just stands for what we call atomic mass units. That's a point of comparison to see how much individual atoms weigh. Now, closely related to the protons are particles that we call neutrons. Now, if you look at the beginning of the word neutron, you can kind of see that it looks like the English word neutral, meaning that it has no charge. So neutrons are neither positive nor negative, but they have the same mass as a proton, 1 atomic mass unit, and together protons and neutrons sit together and make up most of the mass of the atom in the nucleus. Now, these ring structures here are not actually physical structures. These show the pathways moved around by these smaller units here. So these red dots in this structure are what we call electrons, which are our last subatomic particle. So electrons have the opposite charge of protons. They have a charge of -1, but you can see that electrons are significantly smaller than the nucleus, so we say that even though they are technically a particle, they are so small that they basically are treated as having a mass of 0, meaning that they are effectively massless. So these ring structures here, again, are not physical structures. They represent the area or the 3D space where electrons travel. So electrons travel outside of the nucleus through these pathways, which we can sometimes call orbitals, or other times they are simply referred to as shells, and shells will be the more common way that we're referring to them in this unit. Now, we can see that there are different numbers of shells that exist for the atom. We can see that there's an inner shell here that has 2 electrons, and we can see that this outer shell here contains 7 electrons. So in this case, this atom only has 2 shells shells, but it can have more than this. The most important shell is this one here because it is the shell that is farthest away from the nucleus, so it is the outermost shell, and for which we give it a special name that we call the valence shell. And in future videos, we'll see how the valence shell is important. In the next video, we're going to look at how we can organize atoms based on these features here, based on the number of protons, the number of electrons, and the atomic mass of the total atom itself, and how these patterns are visible and organized on the periodic table.